Hello everyone. Welcome to the video presentation of a course project of Engineering Exploration. This is Sushma from Team 8 I Division. We have taken the course under the guidance of Radhika ma'am. The course project that was assigned to us is ball launcher. So let us look into the problem definition of the course. So the main objective of a course is to design a portable ball launching machine which launches tennis ball. The machine should be designed in such a manner that its cost should not exceed 3,000 rupees and its dimension should be within 2 cubic feet. The machine should be built in such a manner that it should initiate enough force to launch the ball to a particular distance. After knowing the required specifications, functions, objectives and constraints of the machine, we segregated the points under light ones and separated them into several functions. So the two main functions which will be performed by our design will be to hold the ball and to launch the ball. So mainly, the machine will hold the ball, it will withstand the weight of the ball, and it will also grip the ball in such a manner that it doesn't slip off. And under the function to launch the ball, it will perform these particular functions, that is to launch the ball to a particular distance, it will apply enough force to launch the ball, and it makes sure that the launching unit returns back to initial position after each launch. After knowing the functions and specifications required, we have clustered them into two main units, that is ball launching unit and ball holding unit. So after considering the subsystems and their functions, we designed 4 different models with 4 different mechanisms. Basically, the first design, which works on the basis of feeder mechanism, the design B, which works on the basis of air compressor mechanism. Next is the design C, which works on the basis of rack and pinion mechanism, and design 4, which works on the basis of crank and rocker mechanism. Before selecting the model to be designed, we considered the puck chart. So what is puck chart? Puck chart basically gives an idea to rank the multidimensional options of a particular design. So after rating each design, we came to a conclusion that the design 3, which uses rack and pinion mechanism, is the best design. So based on the ratings of the puck chart, this is the design we have selected for a model, that is fetch launcher. And this design works on the basis of rack and pinion mechanism. What is rack and pinion? Rack and pinion is a type of linear actuator that comprises a circular gear engaging a linear gear which operates to translate rotational motion into linear motion. So the team was clear with the design for a model. So before implementing the design physically, we had to have an idea of the physical dimensions. Hence, the virtual implementation came into picture. Let us look into the first unit, that is ball holding unit, which is implemented virtually. So we have constructed a box-like structure of dimensions 8 x 8 x 8 cm, which holds the ball, and it also consists of an IR sensor which predicts the presence of the ball. The next system is the ball launching unit, which consists of the rack, the pinion, DC motor, steel rods, springs, and other supporting units. The next system is the ball launching unit, which consists of the rack, the pinion, DC motor, steel rods, springs, and other supporting units. Combination of both the units, this is the outlook of the model. So basically, the ball will be placed manually into the holding unit. The IR sensor, which is placed in the holding unit, will sense the ball and gives direction to the DC motor such that it rotates for about few seconds. The DC motor makes the rack move forward with the help of pinion such that rack applies enough force on the ball and the ball gets launched. So this is basically the rack and pinion mechanism on which a model is working. After virtually implementing the model, we tried to design the circuit diagram of the system. So why is circuit diagram necessary? Circuit diagram helps us to trace the circuit and its functions without regard to the actual physical size, shape or location of the component, devices or parts. So this is the circuit diagram. Our circuit consists of Arduino Mega 2560, relay module, DC motor, IR sensor and breadboard, which are connected with one another. So nextly, we tried to figure out what are the materials required to design a model physically. So we came up with a bill of materials of various products which were required to design the product. So basically, in order to design the holding unit, we require foam sheets, nuts and bolts. And to design the launching unit, we required foam sheet, plywood sheet, nuts and bolts, DC motor, Arduino Mega 2560, relay module, steel rods, high tensile rubber, springs, rack and pinion. So basically, bill of materials gave us a picture why we require the particular material to design the model and also helped us to estimate a particular cost. Since a model consists of DC motor, we need to have an accurate idea of the speed of the DC motor to be used. Hence, motor sizing came into picture. When we considered various formulas, we came to a conclusion that the rated RPM of the DC motor which we will be using in a model would be 1000 RPM. And the power of the battery which we will be using would be 12.56 watts. Nextly, we tried to figure out the functional specifications of the system. So in order to hold the ball, a cubical box of dimensions 8x8x8 cm is designed. In order to launch the ball, the DC motor is used. In order to launch the ball to a particular distance, the pinion applies enough force such that it is launched to a distance of about 40 cm. To apply enough force, we require rack and pinion. And in order to ensure that the launching unit will return back to its initial position, there is usage of high tensile rubber. So let us have a look into the flow chart or the Simulink model of the entire system. So this is the flow chart. As we can see, we have included 3 pins, one input pin and 2 output pins. So input pin is with respect to the IR sensor which senses the presence of the ball, and the 2 output pins are with respect to the DC motor which will rotate whenever the IR sensor senses the ball. So as we can see, we have included 2 states of DC motor, that is on state and off state. So whenever there is an obstacle in front of the IR sensor, the IR sensor senses the blockage and gives command to the DC motor for rotation. So the DC motor rotates for about 5 seconds and returns back to off state. So whenever there is no blockage in front of the IR sensor, the DC motor remains an off state itself. So this is the entire Simulink model of the system, and the cycle repeats. Let us have a look into the simulation of the model, that is the working of the model virtually. So as said earlier, whenever there is an obstacle in front of the DC motor, it switches to the on state, remains there for about 5 seconds and switches back to off state. And this cycle repeats. This is the end of the video presentation. Engineering exploration helped us to have a good experience with the circuits and helped us gain a lot of knowledge. I would love to thank Radhika ma'am for her help and support in designing our project. I would also like to thank our fellow team members for their cooperation in designing of a project. Thank you for watching.